Yeah, good morning to all the mechanical engineers present across India. I am Udaya Banu. I'm basically an automobile engineer with more than 30 years of experience. Worked in various domains of mechanical engineering, and it is proud to be an mechanical engineer. So I got so much of experience within India and abroad. And this industry 4.0 is where the whole world is heading right now, to see how the maximization of resources can be utilized. That is the major objective. So I wish you everyone a very successful and a commendable contribution from you all in the days to come, because you are the future of the engineering field. Before proceeding, I like to have these contents as below. I always feel that any engineer should be very strong in the fundamentals. So I'm going to talk about the fundamentals. And number two is about the organization. In any organization, how it works and how the interdepartments functions, which is more important for industry 4.0. Number three is about the evolution of the industry, and we come to the fourth point about industry 4.0, actually what it means. Number five is a future factory, how it will look like. Number six is most important for you all engineers who are all looking for, is scope for engineers in industry 4.0, and the survival, how we are going to survive and who is going to survive in this competitive world of industry 4.0. And number 8 is another lucrative one for you all, about the opportunity lying in front of you and in the days to come. Number 9 is the question answer, which I will be more interested to answer to you. Now let me go to the fundamentals. The fundamental, I always say the fundamental starts from the school education, say about from the 6th standard, the fundamental starts. But it is very unfortunate that we are unable to recognize that how the fundamental plays an important role in every action of the life and every action of the work wherever we do. So the fundamental has to be strong to succeed in any corporate ladder or any industry or any work that you are going to do, or any decision for that matter you are going to take, will help you in making it stronger and stronger. The fundamentals will only drive us till you go to the grave. Why I am saying this is, the fundamentals always keeps lingering in your mind, so that you will be able to guide and work and take a decision in a perfect way. As you all know, the fundamentals are taught in educational system and implemented in the industry or the work wherever we are doing it. These fundamentals will never change. The fundamentals are always guiding principle in any of the engineering industry. For example, if you take about the Newton's law, the first law, if you are able to understand very clearly, a thing will be under its own place unless it is acted upon. This many a time, if you are able to have a relational thinking and then try to implement these fundamentals, naturally you will be able to have very clear thought process in your mind till we die, because these fundamentals are going to guide us very effectively in the days to come. Because as of today, I've seen about more than 500-600 engineers interviewed for my purpose in various engineering functions like design, which is the most important area, and quality function, production, purchase, stores and everything. And I could find these engineers finding it very difficult to even calculate the volume of a component. For example, a cylinder of about 15 mm diameter with a 10 mm length. If I ask them to calculate the volume is nothing but area into length and then multiplied by the density of the specific gravity. But many a time the engineers will say, sir, I'll go to the CAD function and try to check it up and I'll come and tell you. So which will take about more than half an hour time, whereas I need it within a matter of about say second. So this is just an example for you learning engineers who are going to come out of the colleges in the days to come. Please be very thorough in your fundamentals, which will help you in the days to come. If you are not strong in the fundamental, it will be very, very difficult. Many people, I have seen many engineers are working very hard without clear-cut understanding of the fundamentals. So fundamentals plays a very, very important role in the days to come. Okay, so I'll move to the next slide of the various functions or the departments in an organization. As you know, the business always runs by the customer, for the customer, and the customer is one of the important figure in any business scenario. Without a customer, no business will prevail in this domain or in this world. And this customer is more focused towards the quality and the systems. Why this quality and the system is kept separately is without a system, any business cannot withstand for a longer time. Similarly, without a quality, no organization can stand tall. Whenever we think about the quality, the first thing comes to our mind in automobile engineering is about the German quality. And now of late, the Japanese are also working very strongly in terms of the quality in the system, and they are trying to capture across the globe business. When it comes to how the quality and system along with the customer is combined, are playing a very important role in various departments or function. I just enumerated here where this plays an important role in the days to come when we discuss about the 4.0 industrial evolution. First is the marketing department, number 2 is the costing department, and then comes the research and development, and then design and development, testing, the product testing before it is getting lost to the market, and the manufacturing where this 4.0 is going to play a much bigger role. And then comes the materials department or the purchase department. You may think about in a purchase department what an engineer do, but many a time the engineer has to look for the alternatives, look for where the materials are available and how it is manufactured. And the stores is another area where even many engineers are working in the stores area, because the stores plays an important role in preserving and storing and having. There are some areas where the shelf life of a component plays an important role. For example, if you take about rubber, the shelf life of a rubber is more important. You cannot store a rubber item for more than 6 months. So the engineer can only know this, how this can be stored in a much better period. And then comes the production department, which contributes directly to the profitability of the organization. Then comes the HR, human resources. L&D is nothing but learning and development, because as I said, whatever you learned in the colleges or academic institution, the learning and development has to happen very frequently. The learning never ends. The learning goes till you go to the grave. And then comes the packaging. Packaging, I always say, it is something like you prepare a good food, and the food, if it is not packed and displayed properly, the food is of no use. Similar fashion, when you develop a product and send the product to the customer, and the way that it is getting packaged itself show how much care, how much quality it is built into the product. So that way, this is more important, that packaging plays a very important role. Then comes the sales and dispatches, where the goods are getting dispatched to the customer. And sales is more important in terms of getting the payment from the customer for the goods which is sold. Dispatch is nothing but the logistic, how it is getting traveled over a period of time and how it comes back. And the last one is the warranty and service. Warranty and service go hand in hand. The warranty sends the data to the customer, to the marketing department, and then the R&D department where they get some improvements. And service is the area where the production department and the manufacturing department plays a vital role in getting it improved. I hope this is clear. I'll go to the next slide about the industrial. It is called evolution, but it is generally called as a revolution, because in 17th century it was the industry 1.0, which is based on the water and steam. That is why the figure I depicted as a steam engine, which is used in making the IC engines to work by use of a steam, because there was no electricity those period. So water played a major important role, and that from water the steam getting converted into an energy. And in the 18th century it is about the electricity, where the electricity is used in a small assembly lines for doing some assembly processes, say about a pressing or a bending or a cutting, whatever it may be, that is being used in a small simpler automation. For example, transporting a good from one area to another area through a conveyorized process, this electricity was needed. And in the 19th century it was about involvement of the computers and automation. Computers were involved in making some of the automation levels. This is being seen, I have seen it many industries where it is being employed in terms of the rubber industry, or in terms of the powder metal industries, or in terms of the heat treatment processes. This computer plays an important role where you are unable to control the area where man cannot access, where the sensors are kept in, and this data is captured, and based on the data the whole control of the engineering process is happened. So that is where in the 19th century it has happened. And today this autonomous system of industry 4.0 is evolving today. And this evolution, or the revolution, I call it as a revolution. This revolution is going to make a lot of changes in the manufacturing, the way what we do. When we say about autonomous maintenance system, any autonomous system calls for high level of the parts quality. What of the part that is being assembled, for example, I'll take an example of an engine, of an IC engine which is used in a two-wheeler or a four-wheeler or a truck, or in aerospace, or in aeroplane, or in the ship industry. Let us take about, for example, a two-wheeler engine, where the two-wheeler engine, the mileage is almost controlled by the total clearances which is playing, and the alignment of the parts to the geometry what is given in the drawing. If the alignment is very wrong, naturally it is going to eat away the whole energy, and that is also going to create some problem in getting a proper mileage of the vehicle. So in this case the clearances between the various dynamic parts is more important. If you are able to manufacture a component to the close tolerances, then that is going to give a very good mileage. If you take about different vehicles, why different vehicles give a different mileage? Because of this particular reason. So if you are able to manufacture a part with a consistent precise dimension, if you take about 100 parts, 100 parts are within the range of about 1% variation, okay, but if there is about 90% variation, that is going to create a huge problem. So this is the area where we need to be concentrating in terms of industry 4.0, where the parts quality plays a very important role. I hope this is clear. Now let us go to the slide 5, where it comes about the industry 4.0. Let us understand what industry 4.0 encompasses. As I told already, there is various departments which are interconnected as a matrix, and that matrix is to collated or combined or have to work hand in hand to make this industry 4.0 successful. So I have enumerated about 8 areas over here, and out of this is not the only limitation. There are many areas that has to be put into the industry function of 4.0, but still I feel that this is the most important thing for all mechanical engineers to have an idea, so that you may be able to understand much better. Let us take about first the top, what is given as the mechatronics or autonomous robots. Mechatronics is being used in automotive as well as in production assemblies. When you talk about mechatronics, it is not only about robots. Apart from that, there are simple X and Y movements, which is more important in capturing the parts or sensing the parts or moving the parts or segregating the parts. Wherever it is required, this robotics plays an important role also. Having done this autonomous robotic system, and the function needs to be captured and that has to be monitored. For that, you need to have some clear-cut data analysis. The data analysis, see, across globe there are many so much of data available, but there are only very few people who can analyze it very perfectly and predict about the improvements what can happen. Many engineers always work fantastically, but they may not be able to do the data analysis perfectly. So the data analysis plays an important role in guiding or supporting or suggesting some improvements which can happen. So the data plays an important role here. Number 3 comes Internet of Things. This is the area where the management gets a lot of data from the team working in the factory to have an idea what is happening in the industry, in the, say, about the palm top or the laptop or even the mobile. They're able to get the data immediately what is happening over there. If I talk about IoT, I can say that you might have seen in many hotel industries, when the buyer comes and takes you the order, he just types in his palm top, it goes to the chef and the chef gets a display and he prepares it immediately, and then it comes in real-time data to you. This is just an example for you how the Internet of Things works, but in industry there are many more things that has to happen where you can identify yourself by mapping the various areas of the industry working and then try to put into Internet of Things so that it comes to your palm top very easily, combination with the data analysis. The fourth one comes about the simulation. Of late, the virtual learning has become very important, because whenever you make some projects which are very expensive, before doing that you cannot go and implement it all of a sudden. You need to have the simulation to be done. As a mechanical engineer, you may be very familiar that simulation is being done in softwares with Pro-E, UG, CATIA and many other softwares, and there are some specific softwares available like ANSYS, and there are some CFD, computational fluid dynamics is being done in many of the areas, and this software gives a real-time data about how this simulation will help you in making the things happen. If you are able to do this simulation very properly, you are able to get almost 90% accuracy level about how this part is going to perform. For example, in die casting industry, which is the 60% of the parts in automotive industry is made of die casting. In the die casting industry, the major problem what we face is about the porosity level. If the porosity is very high, porosity is nothing but a small holes, pinholes, which is caused because of the gases which is get entrapped into the casting, thus creates a unfilling, and that leads to some sort of a prolonged failure or a delayed failure. And this you can see very easily through some of the softwares where the metal is getting injected, and you can see how the porosity is going to cause, and based on that some of the designs are getting modified. For example, say small radius where there are sharp corners, and there are some pressures where it is getting backwards coming to the molds. So this is just an example, and similarly there are many areas. If you take about manufacturing engineering, how before assembling, putting an assembly line, you need to check whether the assembly process is going to happen in a much better fashion. If it is not happening, then you need to see how this can be improved further. And mobile kudu. And then comes the system integration. The system integration, as I said very clearly, it is about how people try to see the various data, whatever is available, because one area where data analysis, the data is getting poured in, and there is another area where data is getting integrated. For example, in an industry, the marketing gets an order, and then the costing department make the costing process, and the R&D makes the design. After that, design and development is getting done, and the design and development once does, then it goes for development where the production, manufacturing, and then materials department to buy the material, and the quality has to have its own quality systems. Everything comes to the picture and that is getting integrated. So this is another important role which plays. And number 6 is about the cyber security. Of late, you young engineers know very well how the cyber security plays important role. Even though we are all vulnerable to the cyber, if you are not very careful about the cyber security, your data getting lost, and there are some areas where you may lose your business because there are a lot many people watching over you. It may be your competitor, it may be your counterparts. So many people are there in the industry watching what one industry doing. So you as young engineers has to be very careful in handling the infotainment media. If the data gets lost, it will be a huge loss to the organization, and nobody can repair it very easily. So please be careful about it. Number 5. Number 7 is about the data storage. As you all know, many times we see this, our computers getting crashed. We are unable to get back the data, and we go on searching, and we don't have much discipline about storing a data in a disciplined way. So whenever you store any data, be very careful about 10-year process. If you are working in industry for 5 years and have a 5-year roadmap, how you are going to store the data, and try to monitor your storage weekly once, and try to clear your clutter, and try to be very disciplined in getting the data within a fraction of a time. As I talked earlier about the system is nothing but how we are able to track a data is one of the main work in getting data storage. If data is able to retract in a much faster fashion, then naturally you are much disciplined. So please be careful about storing your data, and try to have a clear-cut vision how we are going to have a vision for next 5 years or 6 years or even 10 years as a longer horizon, or even if you leave your current working place and joining a new working place, and try to have a forethought. If your successor is going to come and take your data, and he has to try to go on working on it, how it is going to help him in getting started very fast, so that the industry can survive, or even he can also progress very faster than spending at least say about 6 months in searching the data. This I have seen in many industries. Many a time when one person leaves, other person comes in, there is always hell a lot of problem, and we always blame the new guy who has joined it. It is always the predecessor who is responsible for all these actions. So let us be sensible and responsible in taking care of the data storage. And the last one what I going to cover is about the logistics. Logistics, many a time people feel it is something about sending a part or getting down the part or carrying one place to another place. No, there is many things that is going to happen in logistic industry. Of late you might have seen there are so many logistics companies as cropped up in many areas. Even you could see some of the areas like in the region of Pune, Chennai and Mumbai, or in Bangalore and Delhi. You can see a lot of logistics companies here and there. But out of that, which is the best logistics industry, who can take care of your product safely, securely and timely is more important. Logistics is the area where the industry 4.0 has been implemented to the maximum extent, I will say. You are able to track a product where it is, and you are able to get a data on your mobile immediately where it is getting heading up. But there are some cases where after we receive a goods, we used to see there are many problems that have happened. We may be expecting the goods to be rushing to the production line immediately, but unfortunately when the goods reaches our place, it might have already damaged because of multiple handling processes, and this damage will create heavy loss to the assembly line stoppages. When I say about assembly line stoppage, which is very huge, they calculate in Europe, they calculate per minute about $200 or something like that. So which will be very expensive. So logistic is nothing but it starts from the packaging design. Whenever your product is getting designed, that time itself the packaging design has to happen. And the packaging has to be simulated also by transporting as a mock-up transport in various areas, like whether it is an local transport like an auto rickshaw or a Tata Ace vehicle, or it is a big truck, or it is a ship, or it is an aircraft, or whether we are going to send it on an emergency basis through Blue Dot or DHL. That simulation has to be done so that you are secure that your transportation of the goods becomes easier for you to do your business rather than the burden in terms of creating a more expensive. In terms of exports, this logistics are very expensive when you want to rush a goods which got rejected and the customer wants it in a no minute. That time it will be a very restless job for everyone, and the top management will be disturbed every now and then. It all becomes a sleepless nights. So we have to be very careful in logistics. So having covered about a general overview of what 4.0 carries for all of you as an young mechanical engineers, please have it in mind, and if you have any doubt that I may be able to answer you in the post session, but however you can note down your questions and then I'll be able to answer in the end of the session. So I just completed about the basics of what industry 4.0 encompasses. Now I go to the next slide. About the smart factory, how the future factory is going to be. Please bear a minute because the slide streaming takes a time. The future factory, this is the factory what I'm dreaming. The time you guys enter into the industry, of course this might have been already done in some of the areas, and some of the areas you have an opportunity to do it. In the future, I presume it is going to be the machine I just depicted here as a robo which is used in a chemical industry, which is a 4.0 compliant, and this is an industry where the operation is going to happen and the human is just going to be just monitoring and controlling, like how the ATC in airports are being controlled for the planes landing and takeoff. Similar fashion, this human's role will be all these areas which I discussed in the previous slides. This is the thing which you guys are going to do it. If I take an example of a German industry, if you go to any German industry, you could see only the machines working, and only you could hear the noise, and hardly you couldn't see any human beings. The human beings may be hidden, or they may be not visible, they may be operating from the remote areas. But in contrary, the Indian industry, if you enter, you could see only the people. The machines are less visible and the humans are more visible. So much of humans are available. So the future industry that is going to happen in India also, where the machines are going to do a lot of job and the humans are going to do their own thinking and working rather than working physically. The physical works will be transferred to the machine, where the machine moves the material, where the machine handles the material, where the machine inspects the component, where the machine moves this part to the assembly line, where the machine does the assembly, and where the machine does the testing, and where the machine does the packing, and where the machine does the transportation, and where the loading unloading of the product is going to happen by the machines. So this is the future which is going to happen, and you guys have a lot of work to do that. So start thinking about it so that the future is yours. When I talk about a smart factory, it is a continuous journey and a standardized approach, a structured system, and connecting everything. And for above all these things, it is about enabling a beautiful or excellent behavior among the various departments working together to make this smart factory to be really a smart factory. And now I move on to the next slide about the scope for young engineers in the days to come. Here I just depicted yes conventional lathe which is being used in the 80s or 70s, and then it has moved to maybe in the 90s. This has moved to a CNC machine, and nobody is able to see this conventional machine no longer. It is available only with a small workshop where a small maintenance works are being done. This is where it is used, and CNC machine is being operated by a man, and the man does the loading, unloading, and inspection of the parts. If we want to convert this CNC machine into a 4.0 compliant, there are many works that has to be done. Let us see what is in store for you all. Industry 4.0 is not a revolution. I feel it is an evolution, because many more things are going to be evolved. That is where lot of opportunity for you guys. A traditional machine converted into a industry 4.0 compliance. What are works? I just listed on some of the activities what needs to be done. Just have a thought in process. But I could understand from many young engineers who are coming out of the colleges, I could see many a time people are unable to even see a lathe or even a CNC machine, or they never had an experience of working in a lathe. For information, during my days of working or studying in a colleges, we had a tremendous opportunity of there is a practical exams available for us to do a small component in a lathe. For example, a spear. I could remember I have to make a spear in the lathe, in the conventional lathe, what is seen in the top powermatic lathe. Then we are judged whether we are capable of working in a lathe. And there are areas where we did some foundry practices where I need to make a mold and pour a metal and try to see the components come thoroughly. And in terms of forging, I need to heat the metal and try to do the forging, and I have to make an eye bolt by hitting with a hot iron rod with a hammer and make a key shape. And in terms of welding, we have to manufacture a small table and see different types of welding, whatever we see as a lap welding or butt welding. All these things we have done it, but unfortunately there are some young engineers who are struggling in the day, struggling even today in some of the colleges. Whenever this is an example which I'm saying, when I interviewed recently, an engineer came from a private engineering college. He was unable to answer these questions. So everything when you see in the academic or in the textbooks, if colleges are not offering it, please do visit some of the workshops which will help you in getting equipped yourself to become a good engineer or work as an excellent engineer in the industry. So let us see this, how this manual machine can be converted into 4.0 compliant. First of all, you need to understand all these manual controls has to be converted into an automated one by using some stepper motors or some synchronous motors, which you might have studied in your electrical engineering classes. So this needs to be, all the controls has to be automated first. There is no manual movement. Number two is the controls needs to be data enabled, and wherever you have the control, and this control needs to be enabled by connecting or taking out the data in terms of the PLC logics or any other mechanism, whatever you have read in your academic, you have to apply that. And then you need to talk about how you are going to capture the data and transfer, and this needs to be a simulation oriented. If you are able to simulate what is going to happen, then you are rest assured, then your job will be done very easily. And then comes the integration. When you have so many data and you have to integrate the data, once you integrate the data, then you need to analyze the data, what went wrong and how this can be improved and where you can reduce the timing. And for example, if you are using some of the costliest tool where it costs about roughly about 1 lakh in one tool, and those tools has to be calibrated or monitored whether it gives a record life, a record surface finishes, and you need to convert this data into a dashboard. When you convert into a dashboard, naturally it will be available in your palm top for your manager or the management, and they may be able to guide you or support you or improvise you your methodology, and you can have a deliberation among your peer level or the management or your boss level, and then you can try to improvise that. And then coming about the 8th point is about the material feeding. The material feeding has to be done by, say, about some XY coordinate table or some small pick and place robotics. Even if you have the inspection being done online on the machine itself, this is going to help you a lot. And then improvising a machine further and further, which will be a continual journey. So if you are able to do this without any manual interference, and you are able to say very confidently that your machine is 4.0 compliant. This is one of the simple example what I've depicted for you guys, which will be useful. I'll move to the next slide. Who are going to survive? For surviving, it is more important learn, develop and create, which will become a technology evolution. As I said, the challenge we see lies in how one can do this. Evolutionary theory dictates that only the strongest or the most adaptive industry can survive, because the more and more you adapt it, you are able to survive very easily. Many a time people have a lot of wealth, they are lucky, they are gifted, but they are blessed with an unfair advantage. It is not so easy that simply having money will never help you out. You should have a knowledge about how to apply it. If you look at this whole scenario, the task is so daunting one. It is not so easy one, but when you start working, it will be an exciting one, capable of changing our lives much better. So the guy who is able to learn, develop and create will definitely is going to make a technology evolution, and those guys are going to survive in this industry 4.0 successfully. So now let us see the opportunity in various industry. What are the opportunities available for you guys? Is this slide visible to you all? Yes. Industry, current status of industry 4.0. This is what I just mentioned over here. Still, it is an evolving stage in many industries. All types of industry can be complied for 4.0 evolution. Wherever you have a human interface and who interface is not possible because of some other safety issues, the implementation will be easier. What we can do, there is a lot of scope to do that implementation. For example, in a process industry or a cement industry, or if you take in a chemical industry or a sugar industry, these things can be done very easily, where the high temperatures or hazardous chemicals, man cannot go and work over there, and there this implementation is already being done, but there are a lot of scope to improve it. And the level of implementation, as far as I am concerned, is roughly about 30 to 50% depending upon the industry, and the electronics industry has implemented almost 60 to 70%, and I already said about logistic industry has done about more than 75%. And the mechanical engineer's role is more important in all these areas, industry evolution. And there are some industries I just highlighted on the right side. Those industry, one is the machine tool industry. As we saw one of the machine tool in the earlier, how a conventional lathe can be converted into a 4.0 compliant. So the machine tool industry is working very aggressively in terms of employing a robot. In some of the automobile industry, if you are able to see during our in-plant training, you could witness this very easily, where the robots are employed and move in getting the parts located, and the machine does the machining, and it gets inspected, and it moves from one machine to another machine in a zigzag position or in a parallel way. There are many methods of employing a robot depending upon the process of the component. Whenever we want to go for a 4.0 compliant, the most important thing is the volume matters more. If the volumes are heavy, we can do it very easily, so that your return on investment can happen very faster. Otherwise, this is going to cost, or this is going to be loaded in the part which is getting manufactured, which will be very expensive. The part will be very expensive because the whole cost of the automation getting amortized on the particular part. Then comes the textile industry. There are a lot of scope in the textile industry. Many mechanical engineers are working. I've seen in some of the industries where the machine runs in terms of about kilometers, and the machine has to be monitored very aggressively, and one cannot move here and there. Earlier, the human has a lot of interface in the textile machines. Now the robots are getting employed, and there are some areas where the textiles also have some health hazard to some extent. So those can be eliminated by use of this industry 4.0 compliance. And as I said, the electronic industry, which is almost mature to some extent, where the components are getting loaded up by the robot, and it is getting soldered by, in terms of the machine, by dip soldering and dry soldering. There are many methods electronics industry does, and the amount of dust which is getting on these boards will create a lot of problem in terms of short circuiting. So the cleanliness is more important. Wherever the human is there, there are a number of chances of carrying the dust, and that creates another problem for the electronic industry. So the electronic industry is wholly free from the dust, so the 4.0 compliance is very much possible. And then comes the process industry, where the chemicals or analysis, or the what is this called, fertilizer industry, petroleum. These are the areas where the 4.0 compliance is very much possible. And the automobile industry, you might have seen in many automobile industries, the most of the cases robots does all this type of welding, and sometimes the semi assemblies are being done, and even the connectors between the plug and play is being done by the human. They are also working very aggressively in terms of how a human can be completely eliminated in assembling a complete car, so that there will not be any much problem in terms of achieving the quality. We have seen in those industries wherever the human is employed, the possibility of mistakes are more. Wherever the machines are there, the mistakes are very few. The machines are programmed in such a fashion, since we do the simulation before doing any activity, and then it is getting fed into the machine and the machine runs excellently, whereas the human has his own thinking. We are unable to simulate 100%. Human cannot be a robot, right? So that is where the area where the robots or the automation plays a much important role. So it is an excellent opportunity for all you engineers to get equipped yourself and excel yourself in these industries. And there are many more industries where the mechanical engineers scope is sky level. Sky is not the limit. Sky, more than a lot of scope is there for the mechanical engineers to grow in the industry 4.0. And I hope you have understood the maximum. If you have any query, you can write to me and I'll be able to answer. So let me have the question answer session. If you have any questions, I will be able to answer you. Yeah, there are some of the questions which engineers are asking is about how the automotive industry is going to employ, how much percentage it is. As far as I am concerned, this automotive industry as a whole has 40 to 50%, I can say. It is mainly done only in the machining area, and some of the areas like assembly is concerned, it is essentially human oriented, and the humans are unable to eliminate, because still there are many areas industry has to work to employ the robots in terms of assembly. But especially in two-wheelers, the man employed is very high, whereas in the four-wheeler industry it is almost somewhere around 60 to 65% is being done. But they are also working aggressively in terms of how this can be eliminated by putting robots in place. And somebody is asking about simulation softwares in most of the industries. Have seen many a time there are some customized softwares in various industry, and you might have seen in your area ProE has its own simulation, UG has its own simulation, and ANSYS is one of the widely used software for the analysis of the mechanical components in terms of fitting, forming, assembly. And there are areas like for sheet metal there is a separate software. There are separate softwares available for die casting. There are separate softwares available for machining. So likewise, there are separate areas where you need to work very aggressively in terms of softwares. Yeah, robotics, there are somebody is asking about who the robots will work in. Some Lokesh Gaurav has asked some question who the robots will work. I could understand this. He is asking where the robots can be employed or who are the robots manufactured. So I will answer both the questions. There are many robotic engineers as come into picture of late in India that is being aimed at basically for the automotive industry and light engineering automobile industries where the robots are getting employed. And the robots, or even there are some people who are importing the robots, especially Japanese make. Even I have seen in Brazil where the robots are employed just for assembling a water pump of General Motor engine. You have to only feed the component, and the complete action of assembling and sending the product out, finished product out, is done by the robot. There are some very delicate operations where the seals has to be assembled, where the spring has to be assembled. There are some press fitting operation has to be done, and the height has to be ensured. Everything is done by the robot by itself, and the finished product comes very excellent without any single quality problem, and there was no even a single complaint from the customers. I hope I answered your question. Okay, I think 5 more minutes. See, somebody is asking about Bhima Varadappu Ravithateja, asking about question about how much salary you are getting. See, salary to any engineers who are working in OEMs, the salary levels are almost slightly much better in terms of say about you may get more than say about 3 lakhs and above. Minimum any industry starts with about 3 lakhs and it can go up to about 10-15 lakhs also. But once you are equipped with all this knowledge level, and you will become a most preferred engineer in the industry, and you can dictate your salary. There are some areas where only thing is, as I said, be very strong in your fundamentals and read thorough. And I request for the young engineers, please keep your textbooks in your home, which will be available for you to read again after you join an industry. Go back and then take your books and read again, so that will be very useful to refresh you what has been taught in the colleges and how it is being implemented in the industry. Even today I am telling all the young engineers who are joined in my industry, when I ask about do you have a design data book available with you, the engineer says no, even he is not knowing what is a design data book. So design data book is a must one for every engineer. Yeah, somebody is asking about is it suitable for job shop. Of course, if it is you are able to invest money, job shop can be also be done. There are many job industries by where the manpower becoming very scarce. You can employ that where multiple jobs can also be done. Autonomous robot software somebody is asking, but autonomous robot is concerned, there is no specific such thing is available. It is all customized one that I will you can write to me, I'll be able to write back to you. But robotics is one of the area where scope is going to be tremendous in the days to come. So the most important is learning about making a robot, learning the machine languages, and getting accustomed in practice. Please do practice. If you are not able to practice, it is not going to help you. As you know, unless you practice, you cannot go and play in the playing field or in the competition. Similar fashion, when you go to an industry, you have to get practice first. First few years are going to be very learning phase for you all. Those phase, if you miss it, it will be very difficult when you grow in the higher up ladders, and when you get married that is going to be a very tough time for you guys. So my suggestion is learn in the initial few years, which is going to be the future for you guys, which is going to be forever. As I said, the fundamentals, if you have a strong fundamentals, there is no need to bother about it. The fundamentals will guide you and your future will be done with that. Anybody has any other questions? I think we have come to the end of the session, and I'll say thank you for every one of you who have participated. And if you have any queries, you can write to me so that I'll be able to write back and clarify all your questions. Okay, thank you for your patient hearing, and thank you very much. Somebody is asking another question: what specialization is needed in MS for improving in this automation? You can learn about something called the mechatronics. Mechatronics plays an important role in keeping this industry 4.0 very stronger. So you can do it either in US or VIT is also offering, and there are many other colleges offering it. You can join there and get it interested. So Gopinath is asking about the coding skills. It is something about the PLC logic. PLC logic is a separate subject where you have to join in as a specialization, then you have to learn it. You can ask some of your academicians where they may be able to share it with you much better. But there are many PLCs are available in the market. Say the Japanese or Germans or Americans or even people from Singapore also making it. So I don't think so. There is a much differences between the various countries doing it, but you can do it by learning about the various PLCs. Just learn about simple PLC logic that will guide you to go through all these things. I hope I answered your question. Okay, so now I am going to end this session, or if at all have any question, you can write back to me. Thank you. Still people are asking question. Where multiple jobs? What is the career growth in industry for mechanic? So career growth in for IT industry, I could see many mechanical engineers are still working in IT industry only. But when you say about IT industry, if you're getting aligned to an industry where manufacturing is happening, there are people, I've seen many people working for the insurance, and there are some people who work for the banking, and there are some, if you take about IT industry for mechanical engineers, TCS who works for Boeing, aerospace industry, and some automotive industry. TCS is a company which I've come across. Many of my colleagues and my juniors are working there in Boeing as well as Airbus Industries, and they do excellent work over there. Just if you are very thorough with your CAD skills in terms of Pro E or UG or CATIA, whatever it may be, is some sort of ANSYS included in your analysis that will help you to work as an IT industry because I call as TCS as an IT industry because they also cater to a lot of mechanical industries. Okay guys, see you then. Bye. I am ending now. Thank you.